Hey, it's Dan, and in this video I'll show you how to replace the instrument cluster lights on the CB175. This is a 1972 Honda, but you could follow along the same instructions for many other vintage bikes. We're actually going to do an upgrade, so go from standard incandescent light bulbs to LED light bulbs, and we're going to replace the high beam light, both backlights for the tachometer and the speedometer, the neutral light, and the turn signal light. Now, the one thing to be mindful of is the polarity of the turn signal indicator is going to be reversed. So right is going to be one way, left is going to be the other way. I'll show you a workaround of how to make that work with LEDs, which are actually polarity sensitive. The other problem I had is my neutral indicator wasn't working, but that turned out to be an easy fix. I'll show you what to look for to get that working again. So the light bulb sockets are accessible from the bottom of the gauges, but I decided to make things a little easier for myself and just remove the gauges to get more room to work with. To do this, I removed the tachometer cable and the two 10mm nuts. With the cable and both nuts removed, it's easy just to lift up the gauge and use a flat blade screwdriver to pop out the bulb sockets. I also used a Sharpie to mark each socket to make sure I don't mix them up. I went with LED replacement bulbs and got the 5-piece set from Common Motor. The LEDs have a lot longer lifespan, so hopefully I won't need to replace them again. You can check out the video description for a link to the bulbs. To remove the old bulb, just push down and twist to the left. And to install the new bulb, push down and twist to the right. Now, one complication with switching to LED bulbs is that the polarity of the turn signals is different for the right one versus the left one. Here, you can see that the right turn signal's polarity is reversed, so the voltage is negative. Since LEDs are polarity sensitive, this means that the bulb will only work in one direction and not the other. Okay, so we'll make what's called a rectifier to convert the switching polarity to a constant polarity in order to make the new LED bulbs work. You'll need a soldering iron, some solder, some hookup wire, 4 diodes, and it'd also be helpful to have a clamp to hold the parts together while you're doing the soldering. Check out the video description for links to all those things. And here's a picture of the circuit that we'll make. The polarity of the diodes is indicated by the stripe, so pay attention to make sure that you align them exactly the way that you see in this picture. The way that I have it drawn here, you'll connect the blue wires to the bike and then the red and green wires to the light bulb socket. It's not going to matter which of the blue wires goes to which colors on the bike, but you will need to make sure to connect the green wire to the negative side of the socket and the red wire to the positive side of the socket. First, we'll solder the plus sides of 2 diodes and hookup wire together, and also the negative sides of 2 diodes and another colored hookup wire together. Now, the easiest way to solder this is to twist together 2 of the diodes and some hookup wire, and then hold a hot soldering iron tip to warm everything up. You'll hold the hot soldering tip to the joint for a few seconds, and then touch the solder. And once you have the 2 pairs of the diodes done, we'll finish up by soldering the other ends together. I used a yellow hookup cable, and this is the side that's going to connect to the bike. So when I shot this video, I mixed up the red versus green wires. Sorry about that. Just to clarify, we'll want the red wire soldered to the negative sides of the diodes and the green wire soldered to the positive sides of the diodes. So you want to make it look just like I have it in the drawing. Diodes are pretty resilient to high temperatures, but they can get damaged. So try not to heat them more than you need to in order to melt the solder. Next, we'll snip the bulb socket off the bike and connect our new rectifier. Here you can see the yellow wires connected to the bike and the red and green wires connected to the light bulb socket. Remember that I mixed up the red and green wires in the video, so make sure that your colors match the drawing. And once you confirm that everything is working, go ahead and wrap it up with some electrical tape. So, the other problem I had was that my neutral light wasn't working. The neutral sensors can be kind of finicky, but in my case it was an easy fix. I removed the front sprocket cover and just cleaned out the connections. The way this sensor works is that the black lobe held in place by the Phillips screw rotates as you switch gears. When you're neutral, the connection is made and the indicator bulb lights up. What you want to do is make sure that the lobe and the connector that touches it are both clean and that a solid connection is made. You also want to pull out the green wire, clean out both contacts, and then plug it back in and make sure that it's solidly in place. In my case, the neutral light began to work again after doing those two things, so it was a pretty easy fix. Next up, we'll remove the left gauge and replace the backlight bulb. And then we'll remove the headlight to get to the high beam indicator bulb. To do this, just remove the two small screws on the right and left side of the headlight assembly. With the headlight removed, you could see that my bike was actually missing this bulb. Luckily, there were no other problems, and everything worked just fine after I plugged in the replacement LED. And finally, we'll put everything back together.